Right, as it's 2 p.m., should we make a start, Sherry? We've got lots to cover today, lots of very interesting stuff
Sure,
to cover.
sure.
So, welcome back, everyone. Welcome to those again who joined us last week, and a fresh welcome to those of us coming to day two this week. Um, we're going to spend a bit of time, Sherry and I are going to take a little bit of time to think about what we covered last week and then introduce what we're going to cover today. Then we're going to move on to speaking about spare and legacy parts. That's section one. Section two will be about value chain sustainability, and then we have a fantastic panel lined up for the third part of this afternoon. We will have breaks in between as well. I would just like to quickly introduce myself. I'm Jennifer Johns. I'm a Professor of Management in the University of Bristol Business School, and I lead a team of interdisciplinary scholars who are very interested in additive manufacturing and resilient and sustainable supply chains. Sherry, would you like to introduce yourself?
Sure. Sherry Monroe, I'm the Executive Director of the AMGTA. So that's the Additive Manufacturer Green Trade Association. We're a global trade association focused on understanding and promoting the environmental benefits of additive manufacturing across the entire manufacturing and supply chain. So this is music to my ears, all these discussions we had on the first day, and really excited for what we're going to have today too.
Brilliant. Thank you, Sherry. I have some slides to share, so I'm just going to attempt to do that now. Sherry, can you see this?
Yeah, gotcha.
Brilliant. So we just did welcome you and do a short background. In day one, Sherry and I spent about half an hour actually in what we called in conversation, talking about some of the broader issues around sustainability, and we'll recap a little bit on that now. We also talked about design and materials. So I hope you can see there's a logic between the first and the second days, where we started at the start of a process, then thinking about what inputs are required, to then thinking about more further beyond the end of the life of a product and further lives of a product, and then to looking across the whole value chain. And the panel will bring together some of those conversations as well. There's lots of time for discussion built in. Sherry and I last week said that we don't mind being interrupted. Please throw anything into the chat as well. And please do feel free to ask questions of our speakers. Our speakers will be speaking for 10 minutes, and then we have 5 minutes dedicated for questions after each of their talks. Well, that's what we did in day one. This time we've decided to do it slightly differently, in that now we want to combine those questions into after each of those sections. Some of that's for time reasons, time constraints, but some of that is also to try and increase the dialogue and the connection between those speakers as part of this bigger focus on sustainability. We had lots of conversations around what is sustainability, and we asked the audience what they thought it was. And one person anticipated my next slide, which was to use the UN quote definition: meeting the needs of the present without compromising the ability of future generations to meet their own needs. Something I think came out of day one and echoes my own feeling is that that's a very noble definition, but it also probably needs to be picked, and something more specific. We need to develop our own understanding, maybe, that's specific to additive manufacturing and manufacturing in general, that gives us greater resonance and things for us to think about how we achieve that sustainability once we've understood what we mean by sustainability. So I think that's an ongoing project here, and it's something I'm quite interested to see what comes out of this in day two, to work towards this common understanding of what we collectively mean by sustainability, to move the conversations forward. Sherry, would you like to reflect a little bit, thinking about your industry, your membership, and what they talk to you about sustainability?
Right. So, just as you're saying, Jennifer, sustainability really can mean a lot of things. And when our organization talks about it, we're primarily talking about the environmental sustainability, the environmental impacts. But when you look at the sort of the AM sector, there's sort of, I have it divided into two groups, right? There's the AM technology developers and the AM technology users. And they're looking at this a little bit differently. But for those who are providing the AM technology, meaning the materials, the printers, the software, all those capabilities, understanding what they're doing within their own organizations, but really understanding sort of those scope three. What are they enabling their customers to do? How are they enabling them to be more sustainable? Those AM technology users, and really understanding where those potentials are. And really being able to look at, the deep dive within the materials and the processes, but also looking at that broader supply chain and value chain that we're going to be talking about today. And I think those are some of those areas where instead of seeing sort of a percentage improvement, we can start seeing improvements by factors when you really look at this in a much broader business sense. And so I'm really excited about what we're going to be talking about today. I think, this certainly today is not going to be the end of the conversation. It'll be the end of this event, but this conversation is ongoing, and I think there's really going to be some exciting things coming out of this.
Brilliant. Thanks very much, Sherry. We also asked in day one where the participants consider themselves to be on their sustainability journey. And I think there might be some value in asking that question again, perhaps to people who are joining us for the first time on day two. I can't see the chat, but Sherry, I'm sure you can. So if the participants want to just take a couple of minutes to think about this first question about where you think you might be on your journey. If you answered this question last week, you might want to think if you had more thoughts about this since you last offered your thoughts.
Right. And so while you're thinking about some of those responses, sort of where's your organization? Are you sort of just getting started? Do you feel like you're sort of well on the path? Or, for some companies, they really have a very established sustainability plan and are really executing that. One of the things that we talked about last week also was greenwashing. And that, can come up in many ways. I'm one who's very hesitant to use that term. So I think sometimes what's one person's greenwashing is another person's just getting started. When you're just getting started, you sort of go for those quick wins. You do those things that are tangible and very doable to get your colleagues and your organization on board. And so you go for those easy wins. That sometimes by others may say, oh, that's, not really important what they're doing, but they're getting started. And as we work on this together, we really need to encourage folks, as they're getting started, what are they doing? How are they communicating this? This is a big part of it I see. I think everyone who's developing AM technologies has a great sustainability story to tell. They just may not know how to tell it or understand it, so much farther down the line. So don't be shy. Jump in here and tell us where you think you are. Are you getting started? Do you think your organization is well on its way, or and that's both internal and looking at what you provide your customers with.
I think as we're on the second day of this event, we're also giving us pause to think about where it is that we're heading as well. And I think that as we talk more about the value chain, sustainability, and looking across the whole cycle, essentially, I think we might get a greater sense of really where the ambition lies and where we can end up with this end point.
Yeah. Steve Cox says, I'm involved with getting people to adopt additive. It's some of its other advantages that tend to dominate the conversation. Sustainability feels like it's there, but in the background at the moment. Yeah. I think that's true. I think whether you're looking at sustainability as the main objective or sort of the byproduct of running an efficient business, right? Resource efficiency, less energy, less material, less waste. Those are great business drivers. They also happen to be great sustainability drivers. So sort of regardless of which one's your objective, you kind of get the other one along with it. Joe says our business was making a good start till more urgent issues took over. And I think that can happen. I think particularly, I would say here in the US, sometimes sustainability is sort of that, oh, wow, okay, we have this extra thing to do versus seeing it as really tracking along with the economics. So the more we can, I think, make that case that those things really go together rather than being at odds, I think will be really helpful. Andrew's saying looking for which AM polymers are recyclable, biodegradable, and compliance with relevant standards. Absolutely. I think the materials and how they what can be done with them at the end of life is really important. The use of additive to support reuse and remanufacture need to be talked about more often. Absolutely. I think there's many ways that this can really add. And I think sometimes we get a little too caught up in the part for part analysis, my personal view. And that quite often is using traditional manufacturing as our measuring stick. When really additive can bring so many other things around, reduced overproduction and reduced, parts that end up in the bin that don't get necessarily accounted for in a part for part comparison. So I think being able to understand that much bigger picture, I think is going to be an important aspect of really driving AM adoption. Because really understanding where the users are and what they're trying to achieve and helping them, quite often, I think a lot of the AM users are small departments within very large organizations, and they're sort of trying to push this rock up a hill. And the more we can help them do that, make that case within their own organizations, is to everyone's benefit. Yeah, these are great comments. I think there's many aspects to look at, and as we look at additive, as we all know, additive's not one thing, right? It's not just printing, and it's not just one method or one process. There's a lot of aspects to this, so there's a lot to be explored.
Yeah, and a little bit more recap on day one for those who didn't join us. We talked really about also the overlap in talking about circularity and sustainability and using those interchangeably. I think circularity will probably come out more in the second section of this conversation as well today. Also mentioning the use of AM in hybrid applications, where we're not just using AM, we're using those in combination with other technologies. Also, the idea of not produce, of actually, and Sherry always reminds me of this, actually trying to produce less, making less, as well as thinking about less waste in the things that we do make. There was a thread of thinking about data as well in our conversations last week. And firms seem to be grappling with collecting the right kinds of data and analysing data in order to understand all of the dimension and aspects around sustainability, and using that data to make the right kinds of decisions. That seems to be a shared problem, and also trying to get life cycle analysis to fit the sector or the particular product or the particular application that they're looking at. There was also a thread of conversation around the inputs that are needed into manufacturing, thinking around energy, sustainable energy, the cost of sustainable energy, and then more discussion about materials, different types of materials, the sources of those materials and how we handle them, how those can be more sustainable. We didn't actually manage to not mention skills. Skills comes up in almost every conversation around manufacturing, and they also think about skills. And that's something Joe Young's point actually about how often sustainability can get subsumed by other things that seem more urgent, and realizing some of the challenges around being in business at the moment. And I've done some separate work actually around people who work in sustainability and are often quite vulnerable. Often they can be the first people to be actually fired from a company if a company feels like it needs to make redundancies. So there's also another point around different kinds of who the people are who are leading on these sustainability initiatives. So that was to summarize day one, and I'm now going to introduce to you our speakers for the first section of today. We have Joe Young from AdditiveX, we have Pierre Deveau and Darren Kitching from Speed3D, and Abdallah Nassar from John Deere. So I'm going to ask each of those speakers firstly to come on and share their screen. I will stop sharing. And here's Joe. Welcome, Joe.
Hi, nice to see you. Shall I share straight away?
Yes, if you can, please. Thank you, Joe.
Okay, I will go for it. 1 moment.
Looks good.
Okay. All right, so just to quickly introduce myself, I am Managing Director of AdditiveX Limited, and we were established in 1988 actually as a 2D printer repair company, and we grew into be a European authorised parts distributor. So I've been in the spares world a long time, with tens of thousands of SKUs in stock. Today, we are a UK-based 3D printing specialist, range of technology, lots of different materials, helping people with many different applications, and also doing a parts printing service. And we're talking to customers from SMEs to huge PLCs regularly about spare parts and legacy parts. We have a mixed experience. So on the one hand, it can be quite exciting talking about the possibilities and seeing the huge costs and sustainability benefits. And then on the other hand, regularly feeling a bit frustrated about lack of scale and progress, when sometimes it feels like the technology's there, the materials are there, the software is there, the digital platforms, but not enough companies are scaling. So going back to us as a repair company and an authorised parts distributor, we've lived the problems that you get with spare parts. So the supply chain issues, the long lead times, the obsolescence, high prices, and as a parts distributor, high costs of sort of holding an inventory. And back in about 2012, 2013, when that market was getting very hard for us because printers were getting cheaper to repair, we were looking for a new direction. And so we were very interested in 3D printing as it came sort of onto the desktop and became more affordable. We bought a couple of 3D printers and we tried to make some parts for our own repairs with early success, which really excited us. So, for example, there was a sheet feeder unit which had a broken part which you just simply couldn't buy, the one right over on the right hand side in blue, and we would have just had to scrap it. So this huge big unit would have been scrapped, versus we managed to make the plastic part because it wasn't that hard, and we could then charge the customer for the repair and send them it back. And that was done with engineering managers who didn't have any prior experience of CAD, but he modelled the simple part and printed it. So it was exciting. And at that point, you feel like it's going to take over the world of spare parts. But it hasn't sort of happened at the pace that I thought it would. So if you fast forward, we are helping customers now with their kind of legacy parts problems. And this is just one pretty simple example. A pet food manufacturer with a part from a packaging line, which was machined aluminium, and was breaking about once a week, and the downtime was costing about £5,000 a day, and it was being re-welded by the machine shop guys because they could no longer buy it off the shelf. So with a desktop printer, printing in a material to give extra strength, so it's like a nylon with some chopped carbon fibre and some continuous strands of carbon fibre placed strategically to give the strength, it became a part that would last about 4 months before it was showing wear, versus a few weeks. So longer lasting, even though it was replacing a metal part. Relatively cheap at the time. It cost £45 to print, didn't need any post-processing, came off the printer, could be fitted, and they now owned the printer, they had the file, and they'd made the start on their journey of digital inventory because they could just press print and print another one. A completely different sector, defence, a Land Rover door handle, which can no longer be sourced. Again, modelled in CAD, about 2 hours work for a V1. And that first version was then used. Again, it was printed for extra strength with some carbon fibre strands, but in use it did actually break. So the V2 was to print it, but also to put a hole, which you can see in the model on the screen, all the way through, in which to insert a metal rod. So kind of a hybrid part for extra strength, which we're not ashamed to say that we do and our customers do quite regularly. Sometimes the best thing isn't always to just go with a 100% 3D printing solution. And it's a vehicle as part of a fleet. So again, opportunity to scale. Now, lots of my customers, I sign non-disclosure agreements, loads and loads of things I can't talk about. So the next example is one from printed on one of my machines, or machine that I own, but not one of my customers. And it's in the rail industry, train maintenance. So this part, which you can see on the left in situ, is a seal, a boot seal for a brake system, protecting the system from water, dust, oil and ballast, and needs to be super flexible. So it's actually been 3D printed, originally an injection molded part, been 3D printed in silicon. Version 1, just using the original CAD file, but it had to be slightly redesigned because of the 3D printed process in silicon for adjusting overhangs and angles and so on, but then successfully printed. And you can imagine this kind of situation, having a train out of action because the maintenance and waiting for a part that would take a long lead time. There's a huge benefit. And another example, so this I would say is kind of like a best practice example of, can this technology really be used to scale for these kind of end use and legacy parts? So this is global automotive supplier Brose, based in Germany, with an AM sort of center, one-stop shop center in Germany, using 3D printing for quite a lot of things, but also for spare parts. So this is a door handle module spare part, traditionally injection molded. But one of the problems for a supplier to the automotive sector is, as a vehicle model goes out of, I can't think what you call it, but it's not sold anymore, but it still has to be supported with spare parts. So if this is an injection molded part, then that might mean injection molding a huge volume, which then has to be stored for 15 years, say. A big waste of money, a big waste of space, a big waste of a lot of resources, versus if you could just 3D print it on demand. And this part was very successfully 3D printed using a powder-based technology in a nylon 12 material. So I've totally seen from my experience the way that in maintenance and repair operations, 3D printing can come in and kind of save the day. It can get machines back up and running where there aren't many other options, or the other options are weeks, months. So then I think that's when people get creative maybe, and they maybe look at additive where they wouldn't have before. But you can see there's obvious benefits where parts are just so much cheaper to make a one-off than it is to order from their normal supplier, never mind getting it from somewhere else. And then the way that you just make what you need. It's a lovely thing to just make what you need and not have to buy in extra and hold them and pay for them. So reducing the downtime and extending the life of equipment. So first-hand experience of all of these things and of how customers suffer from the heavy cost of that unplanned downtime and the heavy cost of the inventory, which has basically been mass-produced and shipped around the world and stored just in case. And typically those models that show what happens to the spare parts, they almost don't show enough detail for me, because I've lived a part in the distribution element where it adds a whole extra level of complexity. The parts don't just get shipped from where they're manufactured to one central place in Europe and then go out to regions and to their end point of use. There is actually often a whole industry in the middle with people like us, with a lot more levels of distribution and so much shipping around that it's crazy. This is a really nice example of best practice. Again, machines that we own, but not a customer of ours, but a Danish customer who's a global wind turbine manufacturer and a leader in wind energy with 15 plus manufacturing plants across the globe. And back in 2021, they launched a program that they called Direct Digital Manufacturing, using the platform provided by Markforged, with an aim of being able to produce consistent and up to spec parts, so they were going to pass quality without having to rely on manufacturer or suppliers, and therefore being subject to those delays or quality issues, and without needing specialists in each of their locations. If they've got a digital parts file that prints really successfully, then that can become part of a digital parts library, and that can then be printed at any location in the world. And they've done that on a large scale, because they're at the point of the case study, they were up to 2,000 parts, over 2,000 parts in that digital library, and using them for not just for new product developments and tools, which is often things that people tackle first, but also using it for end use parts, and still maintaining kind of a centralized control of users, printers, parts, part inspection, and ensuring that they were maintaining a high quality. So I think when I reflect on our experience, what keeps me optimistic is that you can see that some people are scaling, but there's just not enough adoption. And the people that are scaling, so there's companies like Vestas and Bros, seems to be that they've actually been on the journey for quite a long time. Typically, they've got maybe a center of excellence for their whole group, and they've maybe been 3D printing for about 10 years now. But then I sort of have to stop and say to myself, no, the technology's changed so much in that last 10 years that actually that the adoption can accelerate massively now, because we've got it's much cheaper, it's accessible to SMEs, the quality's there. So I think we can be optimistic about the use of 3D printing for end use parts and legacy parts.
Brilliant. Thank you ever so much, Jo. That was really interesting to have those examples to bring it to life for us. I'm going to overrule myself and suggest there is scope for some minutes of questions directly for Jo until we do a combined one. Does the audience have any questions? Feel free to put it in. We have chat and question and answer, but I think we're able to monitor both. So choose whichever you'd like. Can I ask a quick question, Jo?
Of course you can.
Thinking. It seems to me there seems to be an immediate need to driving a lot of this is we can't get the part we need because it's a legacy part, and then AM steps in to solve that. At what point does sustainability come into that question? Are we seeing a shift in that, or is it still at the moment immediate need?
Not enough is my instinctive answer. I don't hear it coming up enough, even though it's like it just feels so obvious. But it's like maybe there's individuals over here that have got that responsibility, and the individuals over here are solving just manufacturing problems, and they don't see that they get together and they could align. It's got such big possibility. I don't quite know why.
Yeah, I think part of that is just the discussion has to happen around it. That may not be the core objective. They just, like you said, for platforms that are no longer in production, they're doing sustainment. Being able to get those parts, that's not their main goal at the moment, but they're getting sustainability, but helping them understand and see that, I think, is really worthwhile. Also, Bjorn, you had a question here. It's kind of a long question. If you want to hop off mute and ask your question, it'll probably be better than me reading it. Let's see if he's available.
Oh no, sorry. It was kind of in response to the previous question. I just had a really long time sending it.
Yeah.
So, I don't know. I can mention it again if you want, but like I said, it's really about the previous slide.
Okay. All right. If you want to go ahead and you've got a question, go ahead and mention it.
I was just commenting how a lot of times I sit through these panels. Sherry, I try to attend as many as I can, and a lot of times I hear organizations talk about their sustainability metrics, right? And how I essentially think in my head that eventually there will be like a sustainability score within your organization, just to see if additive manufacturing could work for you, right? How advantageous is it, and how sustainable it is, how green or your carbon footprint, all that good stuff, right? But in a lot of ways, Syntavia deals with the Department of Defense, and sustainment is a little bit more important to them, as opposed to how I guess green things are. Keeping the warfighter active in a lot of ways. Like there's aircraft that are down by manufacturing process that are archaic or castings are really, keeping things, just not in an active setting, so that like, yeah, things like aircraft are just on tarmacs, right? And
Right.
when you consider that combat readiness, it's really twofold. The DoD contractor themselves, the tier ones and stuff like that, they have an obligation, a contract, right, with the government that says they need to have a certain type of readiness with a certain degree of capability from that particular warfighter, whatever you're talking about, whether it's a aircraft or even a device. Um, but then there's also the national security side of things, the potential lives that can be saved by keeping these things in the air or in the sea. And,
Right.
I think that is not considered enough. And I don't know if you can actually quantify that. That's probably my biggest issue in my head. How do you quantify these risk management type approaches, right? But that was just really my
Yeah.
comment. And then obviously,
Okay.
how we can maybe look outside of our organizations to make your sustainability score a little bit better. In the powder bed fusion world, the before and after the powder bed fusion process there's a lot, right? Creating the material for powder bed fusion, obtaining it, the atomization companies out there, the powder companies, even the companies that source the material, and then everything that comes after it, usage of the part and things like that.
Great,
Yeah.
thanks very much.
Okay.
And I think
All right,
that
cool.
that brings up a number of things I think that we'll probably also come to in our panel discussions as well. There are a couple of quick questions here, but if I can, Joe, I'd like to come back to those when we've let the other speakers present. So I'd now like Pierre and Darren to come from Speed 3D, and thank you, Joe. Welcome both.
All right, fantastic. Darren, you're muted.
The camera's off. Can you see the presentation?
We can, thank you.
Can.
Excellent. I hate doing these things. Hey, let's get started. Hello, everyone. Thank you for joining us today. I'm Darren Kitching. I'm the Training and Support Lead in EMEA for Speed 3D. And joining me is Pierre, our Senior Director of Worldwide Education Sales.
Hello, everybody. Thank you for joining us. Darren.
Thanks, Pierre.
Yeah.
Before joining Speed 3D, I spent 25 years as a mechanical engineer in the British Army, working all around the world in Europe, the Middle East, Africa, and the Americas. During this period, we faced many challenges. Aging equipment, some of the equipment that we had dated back to the 1970s and was difficult to keep operational. And some of this equipment is actually still operating within other NATO countries now. So we've got equipment that's over 50 years old that's still being used within NATO forces. Constraints on supply chains meant that parts were widely unavailable. So this compounded the problem of trying to keep older bits of equipment and legacy bits of equipment operational and keeping it in the hands of the users so they could do their jobs correctly. There was also parts obsolescence. So we're looking at companies like Alvis, who no longer existed, produced these vehicles, and there's no one that took up the mantle in order to reproduce these parts. Yet the vehicles are still being used operationally. All of this becomes massively amplified when you move these vehicles into an operational theatre or away from their base locations. The long-standing problem requires innovative solutions, which is exactly why I joined Speed 3D on completion of my service. We're going to look at a case study now. And this is Project Broca. Right now, the British Army is pioneering efforts to breathe new life into the fleet of vehicles and technology. This includes finding new ways to keep vital but older equipment operational and fighting effective. Speed 3D has been proud to work alongside the British Army in its mission as part of Project Broca, using our cutting-edge cold spray additive manufacturing technology to quickly and cost-effectively produce essential spares and tools. The British Army are currently using AM to support a large-scale NATO exercise in Germany. The types of part being created include door mechanisms, communication brackets, and even hooks for IV drips within battlefield ambulances. These parts are crucial for maintaining the operational effectiveness and readiness of the Army's equipment, the Speed 3D plays a vital role in ensuring troops have what they need, whenever they need it, and wherever they need it. And this is essentially the design process that we go through. The same as anyone, because we don't have this big parts bin of designed CAD files. What we're doing is we're actually reverse engineering parts. So we can see in the first slide there, the green part is taken off the vehicle. It's a known good part, and we've reproduced this with off-the-shelf CAD software. We use Fusion 360, but any CAD software that can output an STL file will be absolutely fine. In the second picture, what we can see is parts as they come off the picture. These are sometimes referred to as green parts. What we do then is we put these into a furnace in order to homogenize the material and refine the metal properties. Once they're at the correct material properties that we expect, we can remove them and machine them. And then what you see in the bottom right-hand corner is a fully complete part that's been through this entire stage process. We like to refer to it as design, print, cook, and cut. All of this can be done on site and on location with our expeditionary manufacturing unit, the EMU. It's contained within two containers. And if you see behind me, this is the print container itself. So you're probably wondering how this links into green trade. Well, we can reduce the carbon footprint of making new equipment. There's no need for large batch productions. We make the parts what we need when we need them, and the parts can be produced at point of need, cutting down the carbon footprint of the logistical supply chain, traveling parts all around the world in order to suit our needs. Well, I'll now hand over to Pierre, who's actually going to talk about the cold spray additive manufacturing process.
All right, thanks, Darren. And you're probably wondering, what is this cold spray that Darren is talking about? What's this witchcraft? Cold spray, if you've heard about it, it's been around for about 100 years. It was invented in Russia, but it was put into practice in the 1980s. If you have heard about it, it's mostly for coatings and repairs. That's what it's been used for in the past, right? So if you had a cracked part, you could cold spray some metal powder into the crack, and basically, instead of welding, you would repair castings that way. But about 10 years ago, Speed 3D decided to try to apply cold spray for the manufacturing process, or cold spray additive manufacturing. Basically, what we do is we take a rocket nozzle, we accelerate heated air through it at about Mach 3, Mach 4, and the metal powders basically collide into the substrate. You can see it in this little picture right here. It shoots this jet of air with metal powder particles inside, and just the kinetic energy of the powder hitting the substrate, it binds the powder together into a part. So that's the mechanical process. There's obviously a software side of things, as Darren mentioned. We take the STL, we run it through our simulation software, and then it generates the tool path for the robotic arm to move and print the part layer by layer. So that's how it works. Clearly, in the case of the Brocker project, you can reverse engineer parts by scanning them into the software and then analyzing it, making sure that it's printable. And the benefit is that the process is extremely fast compared to most additive technologies. And it's literally in the name of the company, right? So we're Speed 3D. Very, very fast. We can make big metal parts in a matter of hours, sometimes minutes. Yeah, that's really the benefit. There's others benefits as well. So speed, clearly, I mentioned. Strength, what we can do is we can make parts that are cast equivalent or better. In some cases, we are actually exceeding the properties of wrought parts, which is fantastic. They're very low porosity, extremely dense, because there's no melting of the powder. There's no phase change. We're spraying solid metal particles, and we're ending up with a solid metal part at the end. Again, no melting, no phase change. The parts do have to go into heat treat, but that's really it. So another benefit is the size of the parts. On our medium-sized machine, we can make parts up to 40 kilograms, 1 meter in diameter and 700 millimeters, 0.7 meters tall. So very large metal parts very quickly. And we have a new product that we just announced. It's actually set up for massive, massive parts. We're looking at a 2 meter build diameter, about 1 meter tall, and a 2,000 pound limit to the parts. So again, comparable to very large castings. Now you might be asking, okay, well, what's the sustainability here? CSAM emits much lower carbon emissions, so 60% less than traditional casting, and about 33% less energy, while you're eliminating about 17% of the carbon emissions that would come from shipping as well. So there's a lot of benefits to sustainability. There's everything that we've heard about related to sustainability with 3D printing. That means, reshoring manufacturing, cutting down on shipping, and a number of other benefits in terms of, less labor intensive production processes. But all of these, are across the board benefits of 3D printing or additive manufacturing. But we've got the added benefits of, less CO2 compared to traditional metal manufacturing. So that is it for the presentation. We tried to do it nice and quick. If you have questions, please put them in the chat and we'll try to answer them as quickly as possible.
Brilliant. Thank you ever so much. And thank you for sticking to time. I appreciate it. Pierre James has a question actually about the cold spray, saying, does it work with polymers as well as metals?
So no, it does not. It's a metal process. Polymers have a much lower melting point. So when we do spray the metal powders, that the air is heated to about anywhere between 550 to 800 degrees C as it's spraying. So that's generally well above the melting point of polymers. So it does not work with that process.
I think also, correct me if I'm wrong, Pierre, I think one of the other benefits of this process was also sort of the environmental conditions required for this equipment to be set up is a little less, let's say, finicky than maybe some of the other processes, which really lends itself to being more that forward leaning, especially when you're starting to think about like military applications or being able to be movable. Is that right?
Yeah, I'll take this one.
Yeah, of course, Darren.
So the X-Speed that you see behind me, that can actually be put on the back of a vehicle, dropped on the ground, and within an hour of it being dropped on the ground, it can be fully operational and printing. Because we haven't got highly sensitive lasers that require really intricate calibrations in order to achieve the build-up of material. It's a quick check to make sure nothing's moved. And generally, when we've moved the vehicles about, nothing needs recalibration. Just a quick check, put some powder in, put some power to the machine, and fire it away. So within an hour, a team that's been trained on how to use it can be printing metal parts very, very easily, anywhere in the world.
Fantastic.
So there's one thing to add to that. We spray with air, so ambient air. There's no gases that you need to truck in. So just power and powder is what we need to print parts.
Fantastic. Excellent.
There's an interesting debate going on in the chat section, and I'm just inclined to let that run. As organisers, we'll try and drop in as much as we can. I don't think there's any more specific questions, but Tom Abraham thinks that the process could be adapted to polymers. So perhaps that's something for Pierre and Darren to look into. Might be an interesting research project. Sounds it. I'll take this opportunity then to say thank you to Pierre and Darren. Thank you very much for your time. I'll now ask Abdallah from John Deere to join us now. Thank you.
Thanks, guys.
Hello. Thank
Hello,
you.
folks. Morning, good evening. You might be. Excuse me 1 minute here while I share my screen.
Thank you.
Okay. All right, welcome everybody. So today I just wanted to talk a little bit about Deere's perspective regarding the use of additive manufacturing, particularly for spare parts, legacy parts, and tooling. If you're not familiar with John Deere, we're a $60 billion company in large agriculture, construction, forestry, road building, electronics. We do batteries. We do all kinds of things. But you're likely most familiar with our large agricultural products. Okay, so who am I? So Abdallah Nassar, so I'm Enterprise Additive Manufacturing Lead for Deere. What that means is I serve as a subject matter expert on additive manufacturing within our organization and work with our business units around the globe to understand their needs and help them adopt additive manufacturing where it makes sense. Prior to this, I was with the Applied Research Lab at Penn State for a little over a decade, which is in the United States, a university-affiliated research center for the Department of the Defense, as well as had various faculty appointments at the university. And of course, let me shamelessly advertise a new book that's out, Additive Manufacturing with Metals, by myself and a few co-authors, which really talks about metals additive manufacturing from the fundamental sciences to applications. Okay, so let's talk about additive manufacturing. So first, I want to give some what I think is a reality check from a large OEM's perspective. So additive manufacturing has been greatly oversold as a solution, now running on well over a decade. In 2023, we saw that the additive manufacturing market grew at its lowest rate since 2009. And now reaches somewhere between 10 and 20 billion. The estimates of the actual market size are all over the place, but we can guess that it's somewhere between 10 billion and 20 billion. That's several times lower than what was predicted, say, in 2016. So what's limiting the growth of additive manufacturing? And I think the answer is actually quite simple. It's cost. So additive manufacturing today still remains far, far too expensive to be adopted by large manufacturers. This isn't a consumer product, right? This is a product that's sold to businesses for them to make money. It's a manufacturing product. So in order for a large manufacturer or any manufacturer to adopt additive manufacturing, there has to be a business case, and there has to be a means for them to be able to sell products at the same degree of profitability, but hopefully more than their current products. So yes, you can do many crazy things with additive. You can make unique designs, you can have unique materials, but in the commercial space, those endeavors must be profitable for them to exist. So I just want to make sure that that's kind of baselined and understood here. So at Deere, like many other organizations, we work towards becoming more sustainable. We have well-defined sustainability metrics, but those sustainability metrics must coexist with our requirement to be profitable and to maximize our shareholders' value. So that's the bad news. The good news is that there are many wonderful use cases for additive manufacturing. So within Deere, we have hundreds of polymer printers worldwide. We leverage them significantly for tooling and prototyping applications in particular. A couple of the examples I could share with you, everything from handles for wrenches that we could make out of something like a thermoplastic polyurethane, tooling for our foundry operations, tooling to help us assemble things, route cables, etc. Very, very widely used within Deere. And it's a really quite an easy business case for us. It allows us to build parts that are consolidated, reducing both our design time as well as our assembly time. We can make these parts directly in our factories, so make them right at or near the point of need. very fast lead time. In addition to very fast lead times, limited operator time, so the operator can simply turn the machine on, and if everything runs, they can go do something else. Overall reduced cost. Tooling tends to be very expensive. And what we found with additive manufacturing, if you combine both the labor costs as well as the actual material cost and the machine operations cost, it almost always comes out to be far less expensive than our traditional options. And of course, rapid iteration, which is very, very important with tooling as well. So when you're setting up fixtures or jigs, oftentimes the first component that you try or your first attempt isn't ideal. And so the ability to have somebody near the shop floor, near the manufacturing production line, be able to see what the problem is, go back and redesign it, or tell the designer, hey, I need you to change this geometry a little bit. Or hey, when I try to torque this, everything comes loose. Please fix it, is very, very valuable to us. And for these applications, quite honestly, sustainability is an added bonus. As I mentioned, we do have public metrics regarding our CO2 emissions as a result of our operations as well as our supplier operations. And this oftentimes comes into that story. It's not a huge impact because Deere does many, many, many other things, but it is a measurable small impact to our overall operations. The other maybe good news, now jumping over to service parts, is that service parts, as you all know, can be problematic, particularly for sectors like the off-highway agriculture construction space, where we're often supporting our vehicles and platform for 15, 20, 30 years is not out of the norm. And these parts, as you can imagine, can become very difficult to source. Oftentimes, the suppliers that provided those parts for us no longer exist, or there's some issue with the supplier relationship. That leads to very high overhead costs for us just to manage those supplier relationships for a very, very long period of time and to have to jump from supplier to supplier to keep platforms up and running. As you can all likely appreciate as well, tooling to produce these parts often gets damaged, worn, lost over many, many years. So we will have to repair or purchase tooling to produce a very small volume of components, meaning that the piece price, the individual price of each component that we produce ends up being very, very high in those cases. Oftentimes, you're dealing with things like minimum order quantities, which is nothing more really than an accounting gimmick to bring the piece price down, but then require us to either store parts for a very long time, increasing our inventory costs, or in some cases, even purchasing the minimum order quantity required and then scrapping a large portion of those items because we don't want to pay for the high inventory costs associated with their long-term storage. The other issue with service parts is that oftentimes they can require some special review. If you're going to switch to something like an additive material or an additive process, you need to understand what the original design intent was. Oftentimes that's missing or not well understood. So there's a lot of time and effort that goes into non-recurring engineering costs, meaning somebody has to sit down and try to make a judgment call about what material substitutions are okay, what tolerances are okay, how will now the new selection of material and the new process affect the original design intent of that part, and what risk are we willing to take in order to do that. And I think I repeated minimum order quantities twice. I don't remember quite what I was thinking when I put that bullet point in there. So given all of this, why should we consider additive for service parts? And the answer is well known and kind of obvious. The curve to the right here is, I had to gray out some numbers because this was for some actual use cases that I was looking at. If you look at conventional parts, if you're producing a single part, your tooling cost is going to be essentially equal to your part cost because your tooling costs are going to be very high. But if you're going to produce these parts at very large volumes, then that tooling and that original engineering costs get spread out over your parts and the part price falls pretty dramatically. For additive manufacturing, oftentimes people say that it's a flat cost curve. It's not. particularly when it comes to powder bed or vat-based processes. There is a very quickly dropping exponential curve, and then there's a small oscillation as the number of parts varies, meaning how many parts you can fit in a single build and how many builds you plan to do to create your minimum order quantity required. But the bottom line is that the cost curve for additive is fairly flat. So as your what we call estimated annual units, EAUs, or the number of parts required per year drops, you're in a situation where additive oftentimes is much more cost competitive than a conventional part. It allows us to respond to our customers in an agile way. So we can now, if we can produce parts that are reasonable, that are at a reasonable cost, we can take care of obsolete components, essentially never obsolete a component. And what obsoleting a component means is that telling our customer, sorry, this component is no longer available to purchase because the number of orders per year has fallen to 1 or 2, for instance, and we can't profitably provide it to you anymore. It allows us to do low risk concept testing. As well as there's another often overlooked aspect to service parts is that repair. So John Deere has repair operations and remanufacturing operations. Other organizations, particularly in the large ag and construction space, have these operations as well. Using additive manufacturing for repair, for direct repair and refurbishment of parts, does often make a lot of sense. We can do that potentially at a profit in some cases. In some cases, we can also repair components that are just really, really required, maybe not at a very high profit, but still that will make our customers happy and gain their further trust. And of course, having the ability to increase part availability, reduce storage times, print on demand, you all kind of, I think, have a very good grasp of those concepts as well. So the comments that I want to leave you with are that additive manufacturing does have significant potential, but it really requires a very focused effort to execute, and it requires the ability to see beyond the hype or the advertisements that are out there. In order to implement additive manufacturing and to do so in a way that makes sense, you really have to be willing to have some degree of innovation and risk-taking within your organization. You have to have some design flexibility. It's almost always the case that you're substituting a conventional material with a slightly different material. So you have to have quality engineers on board. You have to have people who are willing to adopt new designs and understand the risk involved in adopting those new designs, as well as not require stringent efforts towards verification that a part will work, meaning testing that end component, because that can take up a lot of money. And quite honestly, additive for very large parts, at least from what I've looked at and tried to analyze, really doesn't often make sense. So your use case is going to typically be limited to fairly small parts. And when I say it doesn't make sense, it's just not economical. It's much better to stay with smaller parts on the order of 100 by 100 by 100 millimeter, in my opinion. That limits the number of use cases you can look at, certainly, but the vast majority of cases are going to be in those smaller size parts today. We'll see as the technology evolves. Big hurdles that you really have to be aware of are that oftentimes the design of service parts are not well suited for additive. They're blocky. They don't make a lot of sense. Redesign is usually required, but that brings up a lot of questions when you redesign a component, particularly a legacy component. There's often little incentive to take those legacy components, switch them to an additive part, and then go through the entire validation and testing processes that would traditionally be required for any part you introduce into service. You have to have some degree of effort or background understanding how the additive materials and microstructures being produced map to the conventional materials and microstructures. So you have to have quite a bit of ground level knowledge and materials data already developed within your organization. And quite honestly, one of the biggest pain points is you have to either be willing to make the parts in-house or bring suppliers up to speed on how to produce your parts per your requirement. today, frankly, there are very, very few cost-competitive, production-ready, audited additive manufacturing tier one suppliers. There's a lot of OEMs selling equipment, selling machines, but there are very, very, very few. I can probably count 3 or 4 in the world that we would consider cost competitive, production ready, and can produce parts for a large OEM like a John Deere. There needs to be such a much larger emphasis on the supply chain, bringing up these suppliers, whether they be small manufacturing enterprises or even large enterprises, bringing them up to the level required to produce for a large company like Deere. And all of this requires very long-term planning and support from management. The final thing that I want to kind of leave you with, I keep emphasizing this point again, but our direction for everything we do is that we have to deliver exceptional financial performance for our shareholders. We are a public company. Every public company, particularly in the United States, has the same mission. So we are committed to sustainable outcomes for our customers, creating long-term value and making a difference in the world. But the first thing that we will always focus on is being profitable and delivering exceptional financial performance. And if additive can help us get there, we will adopt additive. If additive cannot help us get there, we will not adopt additive. Same thing with sustainability. We have very important sustainability metrics. We're committed to them, but we aim to achieve sustainable outcomes while delivering exceptional financial outcomes for our shareholders. Thank you, everyone.
Thank you. Thank you very much. I'll open up to the audience now if there's any questions. Oh, Sherry, you're muted.
Sorry about that. Hey, great presentation. I always love hearing you talk about this stuff. It's always a little bit of a, at times can feel like a little bit of cold water, but that's what we need to hear. The realities of what does adoption look like for manufacturers. What is it going to take for them to do this? What do they really need, and where are those real opportunities? I think is really important. Your comment about the intention of these legacy parts, where you have an old part. My dad, many years ago, worked in engineering at John Deere, and I can imagine parts that were oftentimes probably almost over-engineered simply because, it's like remove the minimum amount of material to get it to do the job. But then when you look at it later, trying to figure out what does this thing really need to do, I can imagine that. And that's not something I've heard a lot about. So interesting perspective. But yeah, this was terrific. Let's see what else we've got questions here.
I can also open up if there's any questions for any of the other presenters as we head into our first break. Are shareholders always only interested in the financial share? Could they say, we want you to reduce commercial returns and increase sustainability? Excellent question.
I don't know if I'm qualified to answer that question. I can tell you that, there are organizations certainly across the world that are now that are trying to do things like invest in companies that are more sustainable and that prioritize that. There are, I think, organizations that have scorecards for various organizations that try to prioritize sustainability. I think in large part what I hear from our management, and I think my impression is that at the end of the day, our stock price is a key metric that everyone is very concerned with, and all public companies are concerned with, and that is largely driven by our profitability. And as we continue to be profitable, we will continue to have people buying our stocks. If we sacrifice profitability for sustainability, I don't think that's something. And I'm not speaking for John Deere. This is again way above my pay grade. If we sacrifice sustainability for profitability, whether that be long-term or short-term profitability, I don't think that's a decision many organizations at this point are willing to make. I think most organizations are at the point where we need to be profitable and we need to figure out how to be sustainable while maintaining our profitability.
Yeah,
I think that's just the reality.
This discussion very much echoes conversations we had at MAC when I presented this. It was a general manufacturing conference about actually thinking about different types of ownership of firms as well, and whether different types of firms have greater capacity to think more long term. I think there's a short termism around this as well. Chris has a very pertinent question. He asks you, if cost isn't paramount, how much cheaper do you feel the industry needs to get for further AM uptake from a John Deere perspective?
I have a very concrete answer, but I can't give it to you.
Wait for the bag.
So I'll give. So for example, for metals additive manufacturing, I think I'll give you just a general notion, and it's very difficult to talk about this because there are some companies that are doing a good job and really need to bring their costs maybe a few, tens of percents down from where they're at, maybe half of the costs of where they're at today. And they have a path to get there. And we see a path for them to get there. And we work with those organizations. The vast majority of additive manufacturing suppliers, however, need to bring down their costs in order of magnitude. They are providing parts today for the prototyping industry, for some tooling applications. They have not done the required very difficult work to really think about how to increase the productivity of their machines, their processes, their operations, and to really bring down the cost to where it needs to be for a company like a large off equipment supplier, or the automotive industry, which is even more constrained by cost than we are. I think there are many companies today supplying parts, particularly to aerospace and defense, that we look at and we say, this is ridiculous. There's no way we can ever adopt their processes for our applications.
Brilliant. Thank you very much.
Sure.
I'm going to now suggest that we take a short break before we come back to section 2, which is where we'll talk about the whole value chain sustainability. Do we think that 7 minutes is enough, Sherry? Or would you like a full 10 minutes? So. Let's keep us on track then, because that's important, because I don't want to eat into the panel too much. So if everyone can come back in 7 minutes, that's 3:15 UK time. We look forward to seeing you then. Thank you.
Terrific. Thanks.
Welcome back, everyone.
Yeah, really great discussion so far. This is terrific.
Absolutely. Great. So I think we're going to turn to the next section now.
Yes.
Would you like to introduce the speaker, Sherry, or shall I?
Yeah, if you want to go ahead. I think you know our next speaker.
Yeah, yes, I do. I do know two of our next speakers. So I'd like to very much welcome Steve Salt from Rolls-Royce, who's going to speak first. Then we have Sandeep from MTC, and then we have Dan Johns from 3T Additive. So with our welcome, Steve. Nice to see you. I can't hear you, Steve.
Just give me 2 seconds.
Yeah, much better.
There we go.
Got you. Thank you very much.
Takes a minute between pressing the button and the microphone actually working.
Thank you.
Okay, the next challenge then. Can we get the PowerPoint to work? Okay.
Looks like you've got it.
Okay, does that come through okay?
Yes, we can see you. Thank you,
All
Steve.
right. Take it away.
Right. So I'm Steve Salt. I'm from Rolls-Royce in Derby. My main focus of my work for the last sort of 5 years has been on design for additive manufacture, largely based on the laser powder bed fusion side of things, but recently I've been branching out into some other technologies which I'll talk about as I go through the presentation. So, little bit of background. I've been in Rolls-Royce for nearly 25 years, right from an apprentice, back from what seemed like the dark ages. And my focus throughout all that time has been design. And I've seen a lot of new technologies being developed. Additives, just one of them. Composites has always been a big part of things as well. But then we still have the bulk of our components are probably produced in more traditional ways with forgings, castings, turning, milling, drilling, and all that stuff that we know inside out and back to front, yet still managed to get wrong in some cases. So, little bit of background. So Rolls-Royce is quite a big organisation. I'm not from the motor car company. That's something completely different. We're a power systems company, so we produce power solutions for aerospace, for defence. We have nuclear reactors, which we produce for submarines as well as civil uses. My focus is in civil aerospace, and that's what I'm going to talk about today. So when we look at sustainability, we look at our power plants, and it's very easy for the media to point at aircraft in the sky and say, look at how polluting they are. They have huge engines on them that put out a whole load of emissions out the back of them. So we're fighting a little bit of a battle there. However, aviation accounts for only about 2% of global emissions. So although it's very obvious, it's by no means the biggest culprit. But we are looking at a variety of different solutions to improve our propulsive efficiency and reduce emissions coming out of our aircraft. And additive is playing a part of that through reducing some of the emissions in the combustion process. So we talked about the way in which the emissions are being pointed at, and that's only going to get larger over the next 5 years as the predicted in-service engine count is estimated to go up by nearly 40%. So by 2028, we will have a huge amount of aircraft in service. So that's going to be 5,350 engines entering service by 2028. And that's great because we're making money out of that, but at the same time, we've got to do that in a responsible way. So the things that we're looking at in order to improve our sustainability going forward, as well as a lot of things that you don't see, such as making our factories greener, using more sustainable power, thinking about how we impact the environment at every step of the way. We're making big strides in going to decarbonisation and net zero. So we're looking at ways that we can reduce our emissions in the factory. We're looking at new technologies such as more electrification in aircraft, more use of our products through collaborative engagements with other parties in the business, such as the airframers, in ways in which we can work together in our systems design to mean that we are looking at a much more fuel efficient design for future aircraft. So when we look at our products, this is our flying test bed, which we have run over in the US. This is our drive to sustainable futures, and this is an engine which is running on sustainable aviation fuel. And our flying test bed runs solely on sustainable fuel. And that's a big win for us. And we're driving that technology into a lot more of our future aircraft. We recently had the world's longest flight on sustainable aviation fuel, which took place earlier this year. And that was very successful. But sustainable aviation fuel is just one aspect. We're also looking at using other low carbon energy sources, such as electric and hydrogen. And part of the journey through there is to look at new manufacturing technologies that can make components more lightweight. We can use less of these alternative fuels, so we produce less emissions as a result of that. And we're using additive as a driving technology in a lot of the parts that we produce, trying to make sure that we're getting the best use out of it as possible. So there's lots of opportunities for additive manufacturing. And I'm going to talk about a few of those and give some case study examples as we go through the presentation. So we have a number of technologies which we use in Rolls-Royce for additive. So laser powder bed is just one of those one of those processes. We have our own dedicated internal factory for production of those parts, but we also have key links to the supply chain where we can go and get parts made externally, and we try to manage that in the most economic way possible. Up until now, a lot of it has been R&T based, so we've not considered how that scales to a full production run, but it is certainly something we're looking at in our internal factory at the moment for actual production hardware for flying aircraft. We do a lot of DLD, so DLD is direct to laser deposition, which can be either a blown powder or a wire-fed technology, using a laser to provide the melt. We use blown powder in some repair processes, and we're currently exploring using a wire process, not only in repair, but also in original part manufacture. We use FDM, so plastic 3D printing using a variety of polymers for tooling and other rapid prototype parts, which we may just want to do some assembly aids or some visualization of what a part is going to look like. We do that with FDM because it's fairly cheap, it's fairly quick, and it's not as carbon intensive as using a whole metal assembly that we've got to spend time going out and getting forgings and do a lot of expensive machining on. And we can use those parts and recycle them, which I'll talk about a little bit later. We're also looking at using SLA. SLA is quite an old technology when you look at 3D printing, but the quality of the prints has moved on so much, and there's a whole range of new materials that weren't available in the past, which we're now looking at for functional test pieces. So we can actually not only produce rapid prototype parts that look like parts and have a suitable assembly aids, we can actually use those parts now and do functional testing on them rather than having to go out and get real hardware, which takes time and costs a lot of money. So we'll talk about 3D printed polymer waste to begin with. So this was a bit of an eye-opener when I started looking at this, is that when you scale up the amount of 3D printed waste that there is, it actually gets to be a huge problem. So a lot of plastic that you put into a 3D printer is not recyclable. It is not biodegradable in soil, compost or landfill. You need an industrial process to do it. And it's estimated that there could be as much as 1.5 million kilograms of this waste material in the UK alone produced annually. And that is quite a starting figure. So this was a starting point for a project that we worked on last year in our rapid prototyping facility. We wanted to make sure that we weren't contributing as much to that burden of waste material and waste polymer, and have a more responsible reuse and recycling policy in place so that we're more sustainable. So what we do in our facility is we have more of a closed loop or cyclical system. So we will buy in filament from a particular supplier. We will print our parts using our printing farm. Generally, we will have support material on a lot of our parts, although we do endeavour to design them out so that we're actually using less material. Inevitably, there are some instances where you have to support the parts, so that's one source of waste. We do occasionally have failed builds where something goes wrong with the printer. It can be a power failure. It can be that the material is wet and it's not performing at its best. Some of our printers, it can be that the wind was blowing in the wrong direction and they just decided they didn't want to play that day. All of that goes into waste, and because of some of our work is IP sensitive, a lot of it is then ground up and then gets put into recycling buckets. The same can be said for parts that go into service. So successfully built parts, they will go and enjoy whatever life that they are intended for. Some of those parts inevitably might get damaged during their useful life and become waste. Likewise, they will just naturally reach the end of their life when whatever project was going on, whatever type of rapid prototyping we need, or if the tooling is no longer required, they will similarly be ground up, and we will send those back to the supplier of the filament or an associated company where they will grind it down, and they will either use it as a molding additive and going into injection molding process. So that's material that is then not going into landfill, it's not going into waste anywhere, it's being reused and given a new life. There are certain materials that we use which can be melted down and re-extruded into new filament, which we can then buy back from the supplier and reuse it again in our building process. There are some caveats to the produced filament in that it is not always the same quality as the original filament. Sometimes the quality gets degraded simply because it's been melted, printed, ground up, melted again, re-extruded, and you end up with something that's maybe not as good as it was originally, but still suitable for a visual representation of a part and not necessarily a functional component. And we also use plastic 3D printing for cost and waste avoidance. So this is an example where we took our turbine blades, and our turbine blades are coated with a thermal coating to ensure that the metal substrate doesn't wear out and degrade too quickly, because the temperature that these are in is above the melting point of the material. So there's a lot of complex cooling passages in those blades, as well as a thermal coating over the top to protect them. A lot of our customers will do on-wing inspection, where they will use borescopes to look inside the engine and determine whether they think the coating has worn sufficiently that the parts need to come off the aircraft and be sent away to either be recoated or to be scrapped. That is quite costly. So every time an engine comes off the wing, that's costing the airline money because they're not flying that aircraft. We have to supply additional parts and spares. So we ran a training event with our customers where we gave them all a 3D printed turbine blade that was white and matte so that it could be drawn on with marker pens. And this was used as a training exercise for them to understand exactly how worn the thermal barrier coating needs to be before it gets removed from the aircraft. And we were able to do this. We printed 50 blades. The cost was around about £400, but the value that we generate from that in not having those engines come off wing too early is several orders of magnitude greater than the actual cost to make the parts. It also means that we're not producing a lot of waste. We're not taking those parts out of service early enough. So again, that's a lot of waste material that we're not generating, and we're extending the life and making these parts far more useful in future.
Steve, could I ask you to wrap up just in the interest of time? Is that okay? Thank you.
Yeah, sure. Okay. I'll just cover quickly. We use additive for DLD repair. So this is where when we take some parts, we use additive to produce these parts. We'll machine away the tips that are damaged. We'll lay down new material and machine that back to a better quality so that they can re-enter service again. I won't cover that one for DLD. Just want to cover optimization. So this is a optimization technology. It's unlocked through the complexity which we can now produce with additive manufacturing. And the case study example that I've got here, this is an original design which was designed for machine from a forging. That's been reanalyzed, redesigned and optimized so that we can reduce the weight of the components, reduce the amount of fuel is burned, but also reduce the amount of CO2 that comes out of the aircraft. And that's it.
Brilliant. Thank you very much. I was just reflecting on, I think this section is going to be really harder to keep to time because there's so much to cover when we're looking at the whole value chain. So that's really excellent. Thank you very much, Steve. I've got time to take one question from the audience. If anyone's got any quick questions or anything immediate coming to mind, we can come back to this as well. I should imagine, Steve, it's quite difficult for people to keep abreast of sustainability across the whole of a big company like Rolls-Royce.
Absolutely, there's so many different aspects of it, and as much as we would like to, it's not always easy to talk to everybody in different parts of the business, different geographical locations, and we're getting better at it and talking and sharing our ideas. So the what I spoke about around the material that we buy and the recycling of the 3D printing waste, that's a process which has now been deployed in other locations where we have that sort of facility.
Brilliant. Thank you very much, Steve. If any more questions come up in the chat, we'll come back to them later. I'd now very much like to welcome James Knight from MTC.
Yep. Afternoon.
Hi, James.
So, yeah, I'm not Sandeep.
Nope,
so
that was my
there's a big reveal. But,
Great to see you.
Thanks. So, in the interest of sustainability, this presentation is actually a reuse activity. So
Remanufacturing presentation.
I'm going to have to do my best to sort of tailor it to the theme of what we're doing. But let me just get that shared, and hopefully you can all see that. So
the audience is aware, James was asked very last minute to stand in for this talk. So this is not his lack of preparation, far from it. We're very grateful. Thank you, James. Very conscious. I'm also going to demonstrate that my incompetence in using Teams, but am I screen sharing the whole presentation or just the presenter view at the moment?
The presenter view. So yes, that's perfect, James.
There you go.
Is the aspect ratio okay there as well? Because I have a funny screen setup.
It looks a little bit small on my screen, I need to say.
Okay.
Portrait rather than landscape, I think.
Yeah. Oh, this is okay. I might have to work with what we have here. Is it readable or not at all?
Not as much. Would you mind sharing the other screen and put it in? Well, for some attendees, share the window of the presentation and use the reader view mode.
Apologies for this.
No, sorry.
Okay, let's just see if this works.
That's perfect.
Okay, apologies for that. As always, it wouldn't be myself or the Manufacturing Technology Centre if everything went well when it comes to the technology part. And so who am I? James Knight. I have been at the MTC for 11 years now. Prior to that, I was at Lockheed Martin. More recently, I've been actively involved in building capability at the MTC around sustainability. Broad spectrum and church of capability there, and not really a master or expert in the domain of additive manufacture, but I'll do my best to sort of explain how sustainability can feature in that. And I think the theme of the presentation was around the supply chain aspect or value chain of additive. So the theme of this presentation that I'm going to be reusing is more around circular economy and focusing on that aspect, which is a big stepping stone towards more sustainable outcomes. At the MTC, we've produced numerous of examples out there that we can share and show. And there's case studies for a lot of these components justifying their transition from a conventionally manufactured part to an AM part. What we try and do a lot of the MTC is turn people away when they think AM is right for them, but in reality, it's not right for the application. So we tend to sort of be really selective and critical of really exploiting the benefits of additive manufacture. So conventionally in manufacturing, we've come from an age of design where we used to think linearly around how we would produce something, particularly in the consumer realm of technologies, where we think about this take, make, waste philosophy, natural resources to a disposed product, single-use items and stuff like that. In the world of AM, that's probably less relevant. And if you think about things around you at home, a conventional biro pen would be something that you could treat as a disposable commodity. But if someone bought you a fancy pen that was very expensive in a gift, you probably wouldn't even contemplate throwing it away. But you would take the effort to maintain it and keep it going. So with that respect, that's kind of where we sit with the AM world at the moment, in sort of, and it features heavily already. And some of the examples given today sort of really emphasize the applications for additive manufacture to achieve and realize some of these loops that may have been lost with time. I keep saying recently that we have entered an age of reinvention. So what came before, we can do better. And the technology such as additive manufacture and other technologies out there are really opening up the potential for that. So we can do better in two ways. One is thinking from the start of a circular approach to a product's life cycle. How do we maximize its value and usefulness at the most impactful stages of its life cycle? And equally, how do we plan to build that into a system of systems that works for a more sustainable future? So two aspects of the design process that we consider. And when it comes to thinking about the reduction of circular economies, we start at the top of the pyramid with, preventing waste in the first instance. So as I mentioned before, we tend to have a lot of conversation with clients around not using AM for their application, and that's preventing waste or misappropriation of technology. We start to think about how can we reuse what's produced and how can it be reused from such as make from waste, or the main extending the life of a product and increasing its usefulness. Repurposing at the end of first life, as we like to say, and finally recycling is typically where most things from the AM realm end up. With polymers, there's the opportunity for recovery as well in terms of energy harvesting, but more often than not, I think a lot of these things at the moment end up in landfill, and I might, if I'm quick enough, get to a point as to why that might be the case. When we think about sustainability, I think everyone at the beginning of this meeting was talking about it's not just that environmental aspect, it's economic and social as well. We have to consider the three parts to the equation. Quite often we traditionally in engineering focus on the economic and the techno-economic problem solving. We sort of give less consideration to environmental aspects of design development, and that needs to change. But equally, we sort of the social part tends to work for itself. Society will adopt and use our products in ways that we didn't expect. So that planet people profit thinking, how does it all come together and translate to things we can do? So another bit around prevention in AM is this, the fact that we're able to sort of reduce the amount of material that goes into a part is one aspect of it, through clever use of design tools. And I'll probably come on to, there's probably a mention of things like topology optimization again in here for mass reduction, which translates often into reductions in energy use in the use phase of a product. So you get that double win. But what we tend to give oversight to is the fact that for additive manufacturing metals specifically, the embodied emissions affiliated with the production of the base materials is quite energy intensive, and normally more so than conventional stock metals that we would use for subtractive manufacture. So we're often forced to make this trade-off of a decision-making process of, do we increase the embodied emissions to the benefit of having a reduced overall life cycle emissions? And that's one of the key things that really needs to be challenged and built into design development pathways for use of AM. We can do more with less, but equally this important aspect that we talk about is buy to fly ratios. This is one of the sort of common language measures that we're using in terms of how much material actually makes it into the final part. So the diminishing returns as you go through subtractive manufacture stages and losses through non-conforming parts. We have the same issues in AM, but there's a remedy on the horizon, which is the in-process monitoring that can increase right first time builds. But equally, as AI tools and analytical tools improve, we're able to sort of prevent and predict the best use of the equipment available to us. Examples of where we can sort of design better products by consolidating features and function, and also that I've mentioned before around the topology optimization. But we can also play around with the material construct of products. So I think there were some examples earlier of handles produced not from metal, but from carbon fiber polymers, giving increased durability. And these are some of the things that can be exploited, particularly in the repair and maintain space of a product in its life cycle. Thinking about replacement and standardization and having interoperability across products is something that we can do in this reinvention space. I think most of the people in this call are probably beyond the thinking paradigms of let's just 3D print it. And there's a missed opportunity if we don't maximize the advantages that additive manufacture provides in terms of building improved solutions, but we have to recognize that that's not always achievable when it comes to sort of legacy and existing assets. Recertification and requalification of the system level or at a system level is much harder to achieve and more expensive. So it's often sort of a technology that's associated with next generation products, but there's definitely opportunities to go back and redo what we've done before. Second use, this is some work that's been done around powder recovery. So mentioned earlier that energy intensity of powder manufacture is one aspect of the embodied emissions that really needs to be factored in. But there's definitely opportunities to reprocess and recover as much of that as possible and reuse it and lean down these processes so that the additive manufacture becomes more sustainable generally through a lot of these improvements. And we've talked about repair today and how we can go from very long lead times for specific strip down redress to in situ repairs in some instances and rapid turnaround, which is particularly useful in legacy asset maintenance when a lot of the design knowledge or the black book of engineering has been lost with time. Lots of opportunities to reduce the demand for new material, for raw materials through, as mentioned earlier. But this is one of the spaces where we could do better. Part marking and identification, the ability to sort and separate wastes at the end of their life gets lost often through not having sufficient surface areas to include traceable aspects of what is the material type from a characteristic standpoint, and what actually is it that we're disposing of or trying to recycle. So there's lots of opportunities in this space using additive manufactured technologies in conjunction with digital engineering practices, where we can look at blockchain technologies, for example, as a way of tracing hardware through the system. I think the biggest space it operates in, and this was mentioned before, is the low volume production at the moment. Will we see the transition to higher volume production? I think that's something that the markets and economies will dictate. I think I mentioned in the chat that when it comes to the techno-economic problem, if we don't solve either of those, we haven't created a sustainability problem. By which I mean, if it's too, if it doesn't work and it's too expensive to do, is it actually going to become a thing? And does it actually then, as a product, create an issue around sustainability? Probably not. There's always going to be exceptions, but in the main, that holds true. So the adaptation and the growth of AM provides opportunities to really start thinking early around the sustainability of the technology as a whole, which can translate to individual spaces where technological developments progress. But other benefits embodied in some of the examples given today, the decentralized manufacturing or distributed supply chains, quicker route to market, and particularly in R&D spaces that we've mentioned before, and that elimination of upfront tooling and equipment costs, which is an interesting point because a lot of the time within a life cycle assessment, we don't really factor in the equipment part of that process or proportional contribution from the equipment. We only really consider the consumed items and base materials that go into the actual product. So I think the benefits societally, we talk about access for education. I think the example given earlier of the training aid is a really good real world example of how that comes into practice. But the main ones are the around the sort of the speed and turnaround times associated with the technology. I think there's been lots of chatter in the group conversation around some of the challenges, and I think recertification, requalification of a system level is a big one. Knowledge around sustainability, is this solution actually more sustainable than what came before? It's a growing knowledge base, and there's more and more revelations each day. Specifically with polymers, there's a growing realm of organically synthesized polymers being used in additive manufacture applications, which is by its own right more sustainable through it being a natural material and not mineral based. Is this part of the solution in the future? I think when it comes to knowledge, there's also a gap in having access to the evidence that's being produced by companies doing their own studies. I think mentioned in the call earlier was the greenwashing, but the opposite problem is probably more prevalent in what we do. The green hushing effect of studies that aren't published, information that isn't shared, lack of group learning around what can actually be done differently, and wholesale changes that can be employed that would lead to more sustainable outcomes. These are the things we need to tackle. I mentioned about the energy intensity of the material being a key prohibitor to increased embodied emissions of produced hardware, but there's also the next problem space may be around things like shielding gases in some of the in some applications for additive manufacture, where the energy consumed to produce those shielding gases is quite high. So economic use of gases in production, it's probably more appropriate to welding, but we do see some open air additive manufacture using shielding gases and loss to atmosphere. That's quite a wasteful practice in some respects, and maybe come under more scrutiny in years to come.
James, just so you know, your 15 minutes is now 15 minutes. So
okay.
If you could summarize, that'd be brilliant. Thank you.
Yeah, sorry about that. I fumbled at the start and tried to cover as much as quickly as possible, but there was more to this. But
setting up the next round of conversation, so it's been excellent. Thank you.
No worries. Thank you very much.
Brilliant. Thank you very much. Are there any pressing questions from the audience? That really did give us an excellent oversight of circular economies, and particularly bringing in some of these social and economic issues, which are very important to me and my perspective on this as well. We can come back to any questions. So please, in the audience, if you do have any questions for James, please put them in the chat. And I'm now going to introduce Daniel Johns. We're not related, but we do talk often about what it means to be a Johns. And it's my pleasure to introduce him. And he's from 3T Additive. Hi, Dan.
Hi, everyone. Thanks for having me. Thank you for the invite to speak here. Yeah, so Dan Johns, very quick background for me. I grew up in aerospace through engineering program management into executive leadership. I led the early foundation of additive in Airbus and then moved to GKN to lead from a chief engineer position, the industrialization of additive to deliver flying hardware. Then was invited to Oerlikon to support the business unit to set up operations in the US, some M&A in Germany, etc. And then more recently, I was invited to join the board of BMIT, an Italian company, to lead the acquisition of 3T. So I'm going to be speaking from 3T today. There's a picture in the background. You won't see any additive machines because we're talking about supply chains, or from my perspective, we're talking about a value chain, which is all the operations you need within the business model to deliver conforming metal parts. So my presentation actually is I gave a keynote last week at TCT in the UK, and I thought I'll reuse that and condense it a little bit. Can you see it on the screen?
Yes, we can. Perfect.
Okay, so the title of the keynote last week was Making the Shift to AM Production, because this is a hot topic at the moment. We hear a lot about you can't move into production, machines aren't reliable, etc. But what we've done with 3T, it started off as a turnaround opportunity, that it was a failing company, it wasn't really a manufacturing company. And so we've done a transformation program since April 2021 by putting in a vision and a mission around net zero. If you're going to go towards net zero, the first thing that we observed is you first of all have to step into conventional lean manufacturing principles. So we just adopted an operational excellence program based on lean to reduce waste from a normal manufacturing perspective, built the culture around manufacturing, introduced manufacturing engineering as a function, and then stepped through a continuous improvement program. Sounds all very boring. I haven't mentioned additive yet, but I'll come on to that. We often hear, and this is what the AM industry has pretty much been pushing for the last 20 years, that you can go from your idea, print the part, straight to the customer, you just cut out all that processing in the middle. That's the bit in the middle that we call a value chain, or if it's external, supply chain, we call it supply chain, but it's all the processes you need. So from a metal additive perspective, we don't believe in this model. You still need to do a lot of additional processing to achieve a finished component. So this model, I think from an additive community perspective, doesn't necessarily translate to production metal parts from our perspective. When we look at a manufacturing system, we talk about a value chain because we believe you have to have all the processes in-house. It's a little bit like the single crystal casting processes, which Rolls-Royce, of course, will know all about. You have from your alloying all the way through all the foundry processes, the heat treatment processes, all the finishing processes, inspection processes, all in-house. It's the only way to produce, control quality, control the cost, and produce compliant parts. We believe it's the same for additive. So that's pretty much our business model. Is we call it in Italy a one-stop shop. And we were thinking recently about the metal additive, and from a sustainability perspective, we did a lot of life cycle mapping, and we talked about life cycle analysis earlier in this program. We've done something similar. When we talk about life cycle, we start all the way back. When you look at a metal part, it starts with rocks. So we go all the way back to mining. When we look at that, any metal part, whether it's additive, machining, forging, etc., it starts with rocks. You've got to dig all those rocks out. You've then got to process those rocks, crush them, extract the ore, and then ship that ore all over the world to foundries that then go through multiple heat treatment processes, additional alloying in this example, just to get to a metal stock condition. There's 16 processes here. There's 8 heat cycles in that. With metal additive and particularly laser powder bed, which sort of dominates our footprint, we have 50 metal laser powder bed processes between the UK and Italy, and all the back end post-processing technology as well. But if we look at laser powder bed, how do you get to the metal condition? So we looked at this and said, well, actually, you still need the mining, you still need the ore, but actually the processing to get to powder is only 7 process steps. And then you put that powder into your laser powder bed fusion machine, and you print what we now call a near net billet. So we don't, hopefully there's no machine OEMs on the call, because we tell them that this is actually where your machines sit in the value chain. Actually, you're just a foundry in a box. You're not the finished part. So that part on the screen is just a generic Google image, but we consider that as a near net billet. After that, we treat the rest of the manufacturing process as part manufacturing, using all the conventional machining and finishing processes to continue the value add through the process. So that's our first kind of philosophical step change in an additive business. Is first of all, we don't talk about additive as part making, we talk about additive as billet making, and then you still need then all the post-processing thereafter. So our value chain in-house, it goes from powder to finished parts. So we have the printing in there, but only one of the 21 steps, and actually it's dominated by mostly post-processing. Of course, you need to control all of that. So we have at least 120 controlling documents between procedures, work instructions, control boards. We have normal visual management, SQPDC boards, and we started to embed the digital thread. So we're about 65% digital now. Additive actually offers quite, laser powder bed metal fusion. Additive offers quite an efficient from a labor perspective. So you can do your machine turnarounds and then let your process run lights out. We also have adopted a multiple digital methods in our CNC operations as well. So we run lights out. So we only have one shift, but we produce 10,000 metal parts a year through this process. Most of that's lights out, and now we've moved into quality. So we've now got lights out in the CMM inspection. There is still some labor in there, but in terms of cost of labor per part, it's on average 8 to 10%. So it's becoming much more efficient. As an example, and we get down to the sustainability. This is actually quite old. This is back from my GKN days. We took an A350 Kilbreen bracket. You'll see in the middle of the screen the finished part. This is typically machined from a billet, which you'll see on the right-hand side. That's a buy to fly ratio of 10 to 1. And the right-hand side is the machine waste from that billet. We then looked at, if you introduce additive as a near net billet making and change that billet for a near net blank, and then machine that to finish, you end up with a lot less machining waste. Through that study, and this was with Airbus as well, we saw that a 1 kilogram titanium billet would also require, a 1 kilogram titanium part with a 10 kilo billet requires 26 tons of rocks to be extracted. Same part going near net with additive only requires 9 tons of rocks. When you bring that together, from a reduction in embodied energy, it's 3 times less mining, it's 8 times less feedstock, 45 times less machining. So with 3T, now that we make 10,000 parts a year, we thought, well, let's run the same math through our business by taking the, in our case, the average metal part mass we produce is 0.5 kilo. And then we just use the same maths thereafter. So if all of the parts from our customers were machined from billet, we would create 45,000 kilograms of metal chips. However, with additive, using it as a near net blank, we only produce 1,000, and it's the same maths. If we go to the mining stage, it would require 130,000 tons of rocks versus 43. So this is, for us, you know, when you look at it on a production level, a really key area for metal additive is to start looking at it on a life cycle level, to look at the embodied energy and therefore the carbon values that will come later. So from a customer perspective, it's important for us to observe our customer CSR and ESG as they start to report out their ESG metrics next year. They're busy, and all of us will be in scope 1 and 2, which is what are we doing inside our own business to reduce our energy. Scope 3 is coming, and scope 3 will be where our customers start driving those requirements into the supply chain. So we have to be ready to respond to the scope 3 requirements. Now, with those kind of examples I showed before, it won't take long for companies to start to see that machining everything from billet is going to be a lot higher in energy, embodied energy, than going down an additive route. So we see that we're just, you know, getting ourselves in position. We're starting to do the measuring. We did a case study recently with a customer where the part they traditionally made through machining was 106 kilos of carbon, and through our value chain in 3T, it was 4 kilos. It was 102 kilos of carbon reduction. When we apply that to a commercial perspective, when the carbon tax comes, the original version would have cost an additional 530 UK pounds, whereas the 4 kilos will only cost 5 UK pounds. So actually the commercial benefit will strengthen when we start looking at it on a carbon tax that will be coming. Talking of, because I put these slides in actually last minute because I was listening to an earlier speaker talking about the cost. One of the challenges I see in the AM industry is when I see cost models reported. These are just 4 different examples, not connected at all, but in every one, they talk about the cost of an AM part as being 60–70% of the cost of a part. However, I think in these models, they're just looking at the printing only, and it's not the part. They're talking about the printing of the billet stage, not the finished part. If you look at it on a value chain level, which we can do because we have all the processes in-house, this is actually an example from our dashboard to create the cost base from a pricing perspective when we respond to an RFQ. So in this particular one, this is based on actually an M290, which is one of the slower machines, so it's probably the worst case. With the multi-lasers, it gets better. But in this case, it's 20% is the printing. You'll note as well that powder is actually only 2%, so even that's not as high as you might see. The big part of the subcontract, in this case, this was CT scan. But what we do with the customer is through statistical analysis over the production runs, after N cycles, we can evidence that we've got process control in place, and they can reduce the CT cost. So we actually provide cost down roadmaps, so we can get about 40% of the cost out of the part through that industrialization process. Incidentally, it takes about 70 parameters to create a full commercial assessment of a production volume of parts, and you also need to consider additional efficiencies that might come later. So we're actually bidding on programs that are 3, 4, 5 years in length and at volume. So there's a difference between the early development cost, which is always going to be higher, but then your recurring later when you're in production is then where you can drive a lot more efficiency. So we see commercial modeling of AM parts in a different way because of the value chain. So I showed this again last week because this is more of a rear view mirror of our business. The point here is if you're going to go into production, you need to be efficient. Otherwise you won't be profitable. Machines need to be reliable, else you won't be efficient in production. So this is actually our growth since we put this vision and this plan and the operational excellence program in place. So we acquired the company in 2021. It was a loss-making business. We started to step through this program and we started to grow 60% year on year. And we've swung the company around to profit-making company as of last year with additional efficiencies through this year. We'll get to about 8 to 10% on the EBIT line. The point here is that you can stabilize the process, especially in production, because you're working to fix process parameters and fix nesting configurations. You just have to control all your inputs from your powder, your process, your heat treatment, etc., to get the yield. So you can do it. Yes, you can go into production with additive. You can be more efficient. It does offer a big opportunity from a sustainability perspective over the life cycle, in our view. And you can, as they go into production. So this is our business, and we've still got more growth in front of us.
Brilliant. That's 15 minutes. Are you nearly done?
Okay. I'm done. I was just going to speak to the market, but I think we all agree the market's growing. The last one, I'm just going to put my last slide up because I just wanted to say, if anyone is at Rapid, my next stop this weekend, I'm flying out to LA for Rapid. So if anybody wants to meet me, I'm there.
Brilliant. Thank you very much, Dan. That was excellent. There's scope for a couple of questions now before we go to another break. Indeed, if you have questions for any other presenters, but initially to Dan. Sherry, do you have any questions?
I actually just comment, I mean, really great presentation. The analysis and the level of breakdown of that, I think, is really important, and really looking at all of those factors. And I think that type of analysis, whether it shines a good light or a bad light, I think is really important for the sector. I think we need to see more of that really in-depth analysis and really accounting for everything. And I would love to see more of that across not only the production, but the entire supply chain. Yeah, absolutely. Kudos on that. And hopefully I'll see you out in LA next week.
You will. Yes, thank you.
I think a note and a thanks for the openness and the willingness to share all this as well, I think, Dan. I think we'd get a lot further quicker if more people were willing to share in that detail.
Absolutely.
Alan's added a tongue-in-cheek comment about something to do with your past. I don't think it's a question, it's to make you laugh.
Oh, I can't see. I haven't got my glasses on. Where is it?
Didn't mention the great days of Bloodhound in your potted history.
Oh, I didn't. I skipped it. Thanks for that. Yes, after I left Airbus, I got drawn to very fast cars, so I joined the British team that designed and built the supersonic car Bloodhound. So I did that for 3 years. And I enjoyed that very, very much. But GKN, teased me back in to do something, I would say even harder, and that's to industrialize additive. So I can build you a supersonic car if you want. Additive, that takes a bit longer.
Okay, I think also you can see you're drawing on elements of your career history to come to on this sustainability journey. So I can see when you present that you're drawing on data and information and knowledge going back quite far as well, I think. And I think that really reflects how long people have to spend to develop the expertise to really do this in sustainability terms.
Yeah, and also legislation is coming our way. So actually it's becoming a bit of a perfect storm. So if we can really put the context of sustainability around additive, and play it into the sustainability agenda, especially with Scope 3 metrics that are coming into supply chains, then I think we really amplify our industry in that context, and unlock the investment, and everyone should prosper then.
Excellent.
Yeah, I think we'll see more of that, and I think also going back to Abdallah's conversation and the question around shareholders pushing sustainability. I think for a lot of businesses, it won't come from the shareholders pushing it. It'll come from customers pushing it, and that will drive it into the economics and the share prices by consumers where they spend their money. So yeah, I think whether it comes from legislation or from customers or stakeholders, I think we'll see more and more. And those who are on top of it and ahead of the ball, they're going to be in a great position. Those who are kind of waiting will be trying to catch up.
Yeah, and if you are waiting, don't wait too long, because to create an additive value chain in metal, it will take you several years to establish a factory, get qualified, stabilize. So, you know, get the investment in now.
Absolutely. Absolutely. Couldn't agree more.
Excellent. Well, thank you very much to our three speakers, James, Steve, and to Dan. We're going to take a short break now again, and we'll come back in exactly 7 minutes like last time. So 4:20 UK time, and then we'll start with our panel. So I look forward to seeing you then. Thank you. Welcome back, everyone. So the last section of today is I hope of bringing everything together. So we have a carefully selected panel for you. So I would like to introduce Christina Kurth from Syntavia, Gerrit Lucas from the Aachen Centre for AM, Kedar Rane from the National Manufacturing Institute of Scotland, Len Pannett from Dymonex, and Sherry Munro from the MGTA. Thank you very much. So welcome, everyone. We have all our panelists. Thank you very much for joining us today. In a small effort of coordination, I did ask everyone to think about really their thoughts on this topic for no more than 3 minutes, and I do have a running order, so I'll introduce everyone in turn. I would then like to open it up for general conversation. I think we'll probably draw on some of the things that have already come out of the chat and combine that with our panelists' observations as well. So I'm going to start with Christina, then go on to Gerrit, then Kedar, then Len, and then Sherry. So I shall remember that. You don't have to, but let's start with Christina. Thank you very much.
Thanks, Jennifer. Good afternoon, everyone. Good morning, everyone, depending where you are. Really appreciate to be a part of this Sustainable AM Futures. It's something near and dear to my heart. And it's been really interesting to hear perspective from the industry on different end applications, different uses, and just kind of different additive perspective in general. In my role at Syntavia, I'm the Vice President of sales, and I tend to see it in a very tunneled vision. I tend to look at sustainability from an economic and an environmental standpoint from my perspective, selfishly, and also from our customer solutions and what they're looking for. Speaking of my perspective and Syntavia's solutions background, so my background is aerospace engineering. I graduated from Carleton University in 2009 in Canada. My background and my British connection is that I did work at de Havilland in Toronto for 4 years at the Bombardier Aerospace plant, and then went into work on commercial and executive jet engines at Embraer Executive Jets in Melbourne, Florida. So more of a commercial aerospace background. Then I came to Syntavia, and they have more of an aerospace and defense. We do aerospace, all digital component manufacturing, and we definitely started off with the more commercial space, commercial aerospace, and then went to the defense applications as well, just seeing the different end uses and the complexity. From a sustainable background, I think maybe a little bit ironically, or just maybe even a little naively, I went into this thinking, oh great, additive is perfect because I can reuse the powder, and then also I can design for sustainability and have an aircraft that looks maybe more biomimicry, have components that are designed for additive, lightweighting, strength to weight ratios. And that's what my customers would be looking for. And of course, we have that success today here at Syntavia. We have production components, where we have process control, and we have really, really unique solutions that drive sustainability in the end. But I think one of the things that really drove home to me was a call I had with a customer who once asked about replacing a housing on a B-52. And for those of us who are in the aerospace background, a B-52 has been in service for almost 72 years. There's about 72 out there. And from an economic standpoint, it made more sense to 3D print this housing or additively manufacture it via laser powder bed fusion than go traditionally. So it's really interesting to see both cases, the legacy and replacement, as well as the production and the design for sustainability. But excited to be on the panel again today. Thanks for having me.
Thank you, Christina. Garrett?
Yes, thank you. Good afternoon, everyone. I'm Garrett. I'm a managing director of the ACAM, how we call the Aachen Center for Additive Manufacturing in short. Obviously from Germany, not so much related to UK topics, except that I hope for a knockout game at the Euros this year. So fingers crossed. Yeah, I'm happy to be here. I've been in contact with Sherry quite some time now about regular topics in sustainability, especially in additive. And today has been especially some current day that I've been talking a lot about sustainability topics, because besides I'll do a lot of things in the tool and die making industry. We had a live stream this morning about how to transform the tool and die making in Germany towards more sustainability, towards an eco-efficient way. So moving away from a traditional paradigm of industrialized tool and die making. And it's kind of interesting to see how the different ways between tool and die makers and AM service providers are running currently. And when it comes to spare parts and legacy parts, well, I can add to Christina with the aerospace topics, because just last week my team got back from France. They brought back 500 kilograms of thermoplastic scrap from an A320, which we are currently manufacturing new granulates for material extrusion processes from. So this is our one of our major research topics currently. We're going to trying to scrap a whole cabin of an aircraft, make new parts from it, and we're focusing on certification of the material, and then trying to replace in leasing changes of airlines. So this is a quite time critical and waste critical task. Time critical because the airlines lose money for every day the airplane stands on the tarmac and is not being used. And then usually you scrap a whole cabin when it moves from one airline to another, especially when it's a higher ranked airline looking for a excellent finish in the cabin. So this is something really interesting concerning spare parts and also legacy parts, and one of the pressing topics we encountered here in Aachen in the past months and weeks.
Thank you very much. Kedar, you've used your full name on your thing, so apologies if I was shortening your name.
No worries. Thank you. Thanks for the opportunity. My name is Kedarnath Rane. I'm coming from National Manufacturing Institute, Scotland. It's a part of High Value Manufacturing Catapult. I'm a senior R&D engineer here. So we work on various additive manufacturing process, being laser powder bed or DDR, DD laser, polymers, and even sometimes bioprintings as well. When it comes to reflection, my reflection on various topics that we covered today, as we can see that the first thing first is defects and how we can reduce the defects through additive manufacturing. I think there are many opportunities for us to reduce the defects because the additive nature or layer-wise nature of the process. And as we covered that even with using design optimization tools, we can also use a lot of simulation packages to save material as well as optimize the design, and so that we can reduce the efforts on waste and waste production, or even also on the in terms of scraps as well as supports or anything which is coming as a byproduct of the processes. I'm not that much related to end of life application of the various metal and polymer parts, but we definitely try to reduce the waste in terms of simulation tools as well as optimization of processes, along with monitoring and control. Because when it comes to zero defect manufacturing, because one of the presenters mentioned about Six Sigma and how we can relate it to the additive manufacturing, we cannot have that Six Sigma like part per million defects here, but we should make sure that zero defects per batch, or there is no opportunity for defective parts in AM, to be honest. When it comes to the last part that we discuss is about value chain, creation of value chain. My reflection on that one is when we use a kind of digital model, we anyway saving a lot of things on inventory and all these things. So when it comes to parts as needed printed, we can definitely save on a material size as well as on an inventory side as well. And this aligns us to what we do here as a digital factory. So we make sure that the data is secured and the part or the size of the part is also manageable, so that the digital inventory can also be used for various clients and various needs. When it comes to like just-in-time production or methods applied, the connectivity and other factors like 5G is coming into picture nowadays. So we use these technologies and tools to adapt and save various things in terms of resources, as well as to support the sustainability and sustainable goals of the country and the world.
Thank you very much. Thank you. Len.
Good morning, good afternoon, everybody. Thank you, Jennifer, and thank you and Sherry for inviting me to be part of this panel and event. When I first started dabbling in AM about 12 years ago, I felt like a lone voice in that I seemed to be the only one at the time who was giving any thought to the impact of additive manufacturing on supply chains. If I reflect on today's presentations, and they were all really very useful and informative, I'm relieved that this isn't the case, that many are now considering that question. Now, if we focus on sustainability in particular, I'm quickly getting to a place where I no longer talk about sustainable supply chains, but rather just supply chains. So why? Well, the goals of sustainability and supply chain are essentially the same: to do more with less and waste less. So how does this apply to AM and DFAM as well? Well, as many speakers have already said today, sustainability comes in many forms, from the materials and technology employed to produce items to the waste that comes out of those processes. To judge how AM addresses sustainability in particular, I feel that we need to take a step back and look much wider than those very technical elements. Look at the full picture, at how things are designed, how they're made, and how they're used, and compare those to the null situation of when if they were to be produced traditionally. If we think of the consolidation of parts that simplifies supply chain networks, lowering emissions and so much more, if we think about topology optimization of parts that reduces fuel consumption in aircraft, extends battery endurance in EVs, if we eliminate the need for expensive warehousing space and disposal of obsolete items that removing the need for minimum order quantities results in, if we consider extending the life of assets by addressing obsolescence, repairing things rather than just disposing them. Now, the good news that I found working with several organizations across industry sectors on their AM journeys is that many of these firms are recognizing this. The hard questions, though, come when evaluating what those contributions are. This isn't very, very simple. But maybe we don't need to evaluate the arithmetic too precisely. We just need to be using AM in those ways, given that all of those contributions are positive contributions to sustainability. Because after all, sustainability is not just some arbitrary numerical value, it's a direction of travel. And after all, that's what we all want. Thank you.
Excellent, interesting. Thank you very much, Len. And back to Sherry.
Yeah, so I'll make my presentation or discussion here brief because I've already talked a little bit, but you know, to me, it's really exciting to just have all of this conversation. And I'm pleased, and it's no surprise that many of the companies presenting today are also members of AMGTA and are supporting and participating in our efforts to explore this and really understand the sustainability aspects of additive and promote that. Our organization, our goal really is to increase acceptance and adoption of additive manufacturing because we believe it is a more sustainable practice across the supply chain when used appropriately, as is the case with any sort of technology, and when it's measured and compared appropriately. And so, you know, I joke sometimes that it's a little bit like, you know, whether we're talking about, you know, going after the economic benefits or going about the sustainability benefits, you sort of go for one and you get the other one for free. And that it's a little bit like eating your carrots, whether you're eating them because they're good for you or because you like them, it doesn't matter. Keep eating more carrots. I look at additive in a similar way. If you're implementing this and using it and really leveraging the benefits of additive, you're going to see better outcomes, economic outcomes, and environmental outcomes. But again, it's really important to measure the entire process. You know, we were talking one of the presentations earlier that was really looking at, you know, all the way to the rocks coming out of the ground and what that, you know, the impact of that. And it's important to see all of those steps along the way, but not only in the part production, but beyond that and into the supply chain, into looking at the parts that are not produced, the overproduction that doesn't happen, the ability to change models in a way that we're not used to because we assume everything has to be made in large volume all at once. And the ability for AM to be able to spread production over various models, over various designs, across time and across geography is something that is so ingrained to do the absolute opposite, produce it in one location in a huge volume of one design and then have to burn through that inventory. There's an entire mind shift that can go here where you can provide much better consumer parts because now it's not, you know, I think about General Motors. There's a reason every General Motors car has the same gear shift knob. It's not because it's such a great gear shift knob, but it's because being able to produce that in volume and put it across models is very economically viable. Additive can change that discussion entirely, but it really requires a lot of different thinking, not just on the production side, but across the entire enterprise. And so I think we need to think about it in those kinds of ways. And I also think about looking at parts from the not just the production, but what does the part enable? You know, we were talking about, you know, the discussion around Rolls-Royce and the biofuels and electric flight and some of these other things. And Christina knows me well. She knows I'm no aerospace engineer, but I have a hard time imagining that electric flight, commercial size, big electric flight will ever happen without additive and the type of lightweighting of structures that additive could bring to that. In which case, it's not going to be about the sustainability of printing the part. It's the fact that you're enabling electric flight. That may be where your benefit is, not the part itself, but what is this part enabling? And so, you know, when we think about Speed 3D's presentation, being able to do this on the front lines, Is it the most cost-effective way to produce that part? You know, in a vacuum, maybe not. But on the battlefield, right up close where you can't get materials in, you have to factor in all of that when you're really looking at these discussions. And so I think there's a lot more work to be done around use case studies, really putting numbers to these things, but not just in the production phase, across the entire supply chain. You know, what does it cost to have capital tied up in a warehouse of spare parts? What does it cost to have to ship those parts all over the place? And what economic benefit can you get from being able to provide more choices to your customers because you don't have to produce in such large volumes? There's a lot of opportunities here to look at this, and the economics and the sustainability, I believe, track together. So I'll step off my soapbox now and return it to Jennifer.
I suspect that we could all talk about this for much longer. Yeah. Absolutely. Thank you all. I'm going to open up now to the audience to see if anyone's got anything they'd like to ask the panel to discuss, any questions, any topics. If not, I have some questions for the panelists prepared. I'll give the audience some time to think, but I was wondering if the panelists had any sense of what practical advice they might give someone who's thinking of starting on their journey of sustainability using AM. Any nuggets of initial advice from your experience?
Shall I go first?
Yeah, I was just waiting for whoever had the best idea to leap in.
Okay. So I'm going to build on several of the points raised today. Across industry sectors right now, the key drivers for CEOs are cost optimization, increasing resilience, and improving sustainability. It doesn't matter whether you're going to defense, whether you're going to services, whether you're going to transport, those three things will come up in different guises and possibly slightly different orders. Most often, though, there is a bias to the first two, cost optimization and resilience. AM is a very rare innovation in that it actually addresses all three of those goals at the same time, provided you do it properly. So if you ask for advice, unless sustainability is specifically the topmost strategic goal, couch the business case for additive in terms of cost and resilience, with sustainability as an added bonus. You'll make a lot more headway that way.
Great, thank you, Len.
Yeah, I absolutely agree with that. I think, you know, I went to a military additive conference here in the US earlier in the year, and I just wanted to see around the US military if sustainability was much of a conversation. And the word sustainability, I just got sort of a quizzical look. They didn't say no, but they just like they hadn't thought about that. And so I said, well, what about resource efficiency? Oh, they're very focused on resource efficiency. And I see that as being two sides of the same coin, right? It's whether you're resource efficient or, you know, sustainable, it's really the same thing, but just approached to Len's point, what's the, you know, the objective, and then you get the other one for free, sort of. So I think bringing it to them in the terms that they're looking for, whether they're looking for sustainability, they're looking for resiliency, they're looking for resource efficiency, whether it's, you know, and resource efficiency means a lot of things. It doesn't just mean energy and material. It means money, it means time. There are a lot of factors there. And so, but aligning all of those things together, I know in the US to simply do a sustainability study that doesn't also have a line for economics, you're kind of wasting your time, because the first question people will say is, but what does it cost? So you really have to track those together.
Chris is asking us, do we feel like there's a sense of urgency in the AM industry on accelerating the machines, processes and knowledge adoption? And do we feel it's fast enough? So, I mean, essentially, is AM able to meet some of the sustainability goals as much as we'd like it to yet?
I'd say never fast enough to satisfy everyone.
I see you guys shaking your head, and I would argue that sometimes we have to create our own urgency. So I'm gonna give another example from the defense world, Jerry, where we actually had the customer compile data for us and say, what is the cost of poor quality of not getting this aircraft out and having an AOG versus having a complex component made via additive that's going to go through a little bit more stringent requirements from a destructive testing standpoint. And we created that own urgency. We at Centavia as a team worked with the end customer to prove that it really did make more sense to go via additive from a sustainable economic and environmental path forward. So there is some push from our side too.
Yeah, I would add that it's depending on who you ask. If you're asking a company who's really struggling, a machine manufacturer, for example, they are wanting to have a much faster adoption of additive, but they, I think, struggling with the explanation of the advantages Len pointed out. So they are trying to sell machines rather than selling the solution that is provided by the machine. So that's different. But if you look at the users, IAM users, I would say that the adoption is running fairly fast and fast enough. I would guess.
So when it comes to one point of urgency, I believe that the adoption of topology optimization and some biomimicking stuff is a matter of urgency, because this is very much aligned to sustainability and sustainability goals, because the use of digital technologies and sustainability is aligning just before the actual manufacturing in this way. So rather than producing defective parts, or rather than utilizing the machines effectively, if we can design and optimize the parts, then I think it's more important than sorting the issues later. To be honest, when it comes to optimization of the designs, many of the as you know that many of the people they think that it's like too difficult job, because it's running the simulations, running the coding, and like using some design for additive manufacturing kind of rules is very much difficult. But they are very much important for sustainability point of view, because we can not only see the material which is getting utilized better, but also in terms of overall value chain is affected because of the value which we bring in, the cost, the time, and as well as resource efficiency. All these three elements can be very much rewarded through design optimization, particularly topology and biomimicking things. So I think the adoption of these technologies is a key to start with.
If I can add, I suppose my answer to the question is, if there is a sense of urgency, they're really hiding it very well. The AM Strategies Forum in New York earlier on this year that had several of the OEM CEOs there, they were coming out with unbelievable positive statements and how wonderful it was all going to be. It was like they were still living in the in 2012, 2013, where the AM's share prices were 8 baggers and 10 baggers. That is not the case. The sales of machines has flatlined, if not dropping. If you look at the value of a lot of those companies, they've been dropping because investors are not getting the returns that they hoped, because they're not making the sales that they thought. And part of the problem here is that we've got two things. One is we had a conversation earlier about the value chain of additive. Additive is not something you can just go out and buy a machine and here we go, we're going to use it. There's a whole complicated ecosystem to this. You need data analytics, you need engineering capability, redesign capability. You need the right materials, the right machines, post-processing, testing, and quality assurance. That is a complicated proposition, particularly if you've got to use different agencies for all of those. So consolidation of that value chain is definitely something needed. And the other one is we've got a huge explosion of different machines, different technologies. Like, I remember back in the 80s when the PCs were the big thing, and we had an explosion of lots of little companies, all of them selling their particular thing. If you're old enough, you might remember apricots, as well as Apple. That consolidated over time because standards started arriving, so that there was more openness in the architectures of that technology, and obviously there was consolidation, both horizontal and vertical. We're probably knocking on the door of something similar in the AM world, where we've got way too many companies at the moment, each selling their own little unique specialized solution. And that just makes it really difficult to engage with AM. It's awful. It's a big bet on what could well be a losing horse in a lot of cases. So is there a sense of urgency? I don't know. I'm not seeing a lot of companies opening up their architectures and making life easy for their customers. Quite the opposite, actually. I'm seeing an awful lot more lockdown and protecting the existing lots.
I would like to add one thing, because then you pointed out that the machine manufacturers are doing their itsy bitsy tiny little unique thing, and the machines are still just a general machine that's not specified to customers' needs in any kind of way, and this is making it quite difficult when you compare it to regular machining or milling or even injection molding machines, which is probably the golden standard of a standardized machine, because it cannot do any product by itself. You need a tool, and those kind of machine manufacturers have understood how to tailor their machines to customers, to applications, and give them a solution space. And this is where I agree with you that the industry will probably see consolidation on maybe FDM level, maybe on powder bed fusion level, maybe on the other new emerging technologies. Maybe we see some technologies even cancelled completely out of the current landscape.
I often think that sometimes the urgency can come externally, and I think there might be other geopolitical factors that actually, kind of push and drive change quicker. Sometimes it's quite hard for the urgency to come from within the sector sometimes. We've got 10 minutes left of the session. I'd like, if there's anyone in the audience who has any more points to discuss, I was wondering if we could then, or if there's no questions, think maybe a bit more about what we could all collectively do, perhaps to support each other more, who needs to be involved, what could the AM sector do together, or does it require external help? Any ideas or thoughts on around how we can really create these sustainable futures, given that I think we all fundamentally believe in these technologies to help create more sustainable futures? So quite a general question, but any thoughts welcome.
I'm going to jump in here as a founding member of the AMGTA Syntavia. I really believe that what Sherry's doing and what the members are doing with her for life cycle analysis are really, really, really important. It's really hard for me as a person finding solutions for my customers to sell to a supplier manager the unit price to unit price from additive to conventional. And with the work that she's doing and with the work that I had mentioned earlier, the engineers from our customers are doing, looking at the cost of poor quality, those are the key drivers that can convince us that this, and not only ourselves, but our customers and the end user, that additive is the best path forward. So I think it's really important that we just continue collaborating. Sometimes it's a little bit difficult to collaborate from a proprietary database type background, but certainly for life cycle analysis and looking at the life cycle of an additive component, that's something that we can share and we should work together. Thank you.
Yeah, I'll jump in here. Thanks, Christina. Yeah, I think what Christina is saying and what others have shown is really being able to put these use cases together. I'll say this again, is really important. And it's because it not only puts numbers to the things that we all think or that we all suspect, but it actually puts numbers to it. But you also have to be able to tell the story, right? If, when we talked, I think it's so important that we've had some end users on this session today, because they're the ones who are going to make these decisions to a big extent. What do they need? What are their challenges? What's holding them back? Where are their opportunities? And understanding that and being able to communicate You know, we have to stop talking about features of this technology and start talking about the benefits, right? This is the basics of sales. Stop talking about features, start talking about benefits. And you've got to really be able to communicate that and help them see the vision. Where can this go? What can it do for them? You know, the idea of getting involved and doing it now so you're not caught behind, but understanding what that path looks like. And for some companies, like the expertise required for this, that is a big leap. How do you become an expert internally on this? Well, if you look at a company like Centavia, they're making it so their customers don't have to immediately become experts in additive manufacturing. They're doing the design and the production. Their customers are benefiting from all the advantages of additive manufacturing without having to suddenly become, experts in this. And to compare it back to the, PC revolution, before that, everybody didn't have their own in-house computing expertise. They outsourced that, but they got the benefits of it. And so this will be the same thing before additive gets to that PC stage, right? Of everybody can do it. All you have to do is buy the thing, plug it in, and it goes. But in the meantime, leveraging those companies that really do have the expertise, not just the printing. I'm not just talking about print, service bureaus, but that can actually do the high level design. Is really going to help move this along, I think, in a big way.
If I may build both on what Sherry said and actually, Garrett, what you said earlier on as well, it's as well as the what the message is talk to the right audience. AM still spends far too much time talking amongst itself. We need to spend less time at AM conferences and much more at supply chain conferences, at manufacturing conferences. Those are the people who have the headaches. Those are the ones that the board has said, we have a sustainability strategy, go make it so. So the head of supply chain, the head of manufacturing is holding this thing saying, what do I do? So if we can take that message, take those benefits and show them, so, articulate the cases that we've got of success and show them what the art of the possible is. That's step one. And step two is make their journey easier. It's help them take that first step. So I do a lot, for example, with defense. Unsurprisingly, one of the biggest concerns in defense after certification and IP is the communication of data between points. Why haven't we got simple solutions that mean that we can transmit data from point A to point B securely? We do it elsewhere. Let's start incorporating this in the systematic approach to AM, and we will certainly find the doors start opening and people invite us in more.
Len, I just want to add to that as well. So from a Centavia standpoint, and I'm a bit of a hypocrite because I'll be at Rapid next week, so see you guys there. But we've really been focusing on the supplier, the end user shows, and we've had a lot more success. It's been interesting to see everybody from the leadership and the top down, not just the engineers, be excited about this. And I think, Sherry, to your point, we just need to spread that wider.
Chris is offering us the machine supplier perspective. He's saying it's more in their interest to enable more robust operation of systems, higher reliability, greater utilization of both bed and lasers, and obviously cost, all hopefully contribute to a smaller CO2 footprint. Thank you, Chris.
If I could just give one example, actually a very current example, I was at the International Institution of Obsolescence Management UK meeting yesterday. Crikey. I was somewhat taken aback to discover I was the first person.
That sounds like a really fun group.
It really was, actually. It really was. I was the first person to talk about additive manufacturing for obsolescence management in 10 years. Talk about a captive audience.
Yeah, and I within our organization, we really look at it as we have two audiences, right? One is an additive manufacturing audience where we're talking about sustainability, but the other one is really a broader manufacturing sustainability audience where we're talking about additive manufacturing. So for companies who maybe kind of know what 3D printing is, but really don't, but if they're trying to figure out how are they going to be more resilient, how are they going to have more efficient supply chains, how are they going to cut costs and hit sustainability targets, to be able to come in and use our members' stories, examples, use cases, and say, let me tell you what additive manufacturing can do for your business. Here's what it can do for inventories, for supply chains, for delivering better options for your customers. And their eyes just light up. They're like, we didn't even know this was a thing. Like and so that's what we're doing also, because that will drive more interest, more acceptance, more adoption. You know, that's kind of how we're trying to expand this as well, is really share those stories, those use cases, and really be able to broaden this. And to the previous question, you know, how do we get more people doing this? I know within our organization, by its definition, our members are interested in doing this. If they weren't interested in working together and sharing information, they wouldn't join our organization, because that's what it's about. But those companies understand there's so much potential here in this market. There's so much more to be gained by working together, because you can try to hold all of this tight and keep your cards very close to your vest. And guess what? Everybody that's working together, and you just they're going to just blow right past you. And you just have to look back at any other technological revolution and see that exact same case. We think we're in a new space. We're really not. You can look back at you know, internet, you know, growth. You can look at the PC revolution. You can look back at, you know, the industrial revolution. You can look back at Henry Ford. None of this is new. We already have a blueprint of how this works out and who is successful and who's not.
Brilliant. Thank you very much. I'm going to draw everything to a close, regretfully now, but draw everything to a close. And thank very much our panelists and our other speakers. Do get in touch if you have any feedback on directions you'd like to take these conversations. You may have got the impression Sherry and I are always willing to talk about sustainability in AM, so get in touch with either or both of us. Don't forget the role of academics, myself, Patrick and Alan, in terms of being honest brokers in this game. Draw on us if you want to, if you need to, get in touch, you're more than welcome to. I very much enjoyed these sessions and hearing from different companies, organisations, and I really think we've made some inroads to understanding the challenge of AM for sustainability. So any comments from you, Sherry, or I'll draw everything to a close?
No, this was great. It was really great having everyone participate. These were incredible conversations. These will also be made available if you want to be able to share them elsewhere. Thank you, Jennifer, for all your work on this. It was great partnering with you on this event. And yeah, let's do this again.
Brilliant. And thanks for DFAM for their help in organising this as well. I think there'll be more to come from us. I hope so anyway. So nice to see you, everyone. Enjoy the rest of your day, evening. Take care, everyone. Bye-bye.
All right. Bye-bye.
Thank you.
Bye.
Thank you. Bye-bye.